So I think we can start. We will wait a few more minutes for the people online, but I think we can start with explaining the agenda and the venues of today. Hello and welcome everyone. My name is Isabel. I'm project manager of Solartis, and thank you for coming today. I will present you the agenda for the event. Okay. So today we will start with a welcome. Jordi Ortiz is the director of Solartis. Thank you, Jordi, for coming here today.
No problem.
Then we will present the project and be for Med-EcoSuRe and Ines and Soha from Med-EcoSuRe. Thank you for coming also today. And then we will explain a little bit the Decision Aid tool for energy efficiency retrofit planning in higher education building. Thank you, Jose Luis, for coming. And Jose Sanchez from the University of Seville.
Thank you, you are welcome.
And the toolkit of passive solution design for higher education building retrofitting. Thank you, Antonella, from the University of Florence.
Thank you for inviting me. It's a pleasure to stay with you this morning.
Thank you, the pleasure is ours. Then we will have the coffee break for around 20 minutes, and afterwards we will present the process of identification of innovative emerging technologies. I will be, Leticia, the cluster manager, will be presenting this part, and afterwards we will present our companies, Marilena representing Traumatrin Ambiental, Maria from Sun Solutions, she will be coming here in half an hour more or less. Then Andres from Ingenium, who will be online. And then Isabel from Mendef Engineering, she's also online. Thank you all of you for coming here today. And if you have any questions, well, you can write it down in the chat or just raise your hand up. Thank you. So Jordi, please, welcome. Thank you.
Cool. Thank you. Thank you, Jamie. As Jamie mentioned, for the ones who don't know me, my name is Jordi Ortiz. I'm the CEO at Secartis, and at the same time, I'm the General Manager of Solartis and SmartTech, two of the partners of the project. For us here, it's a pleasure to welcome you all. I want to make a special mention to our partners and the key pillar of Med-EcoSuRe, Marco, Ines, and Soha, who came here in person from Tunisia. Welcome to Barcelona. Despite all the difficulties of COVID and traveling, you made a big effort to come here, and for us, it was great to spend time with you yesterday, and it makes a big difference to meet people in person. So despite all the restriction and everything, it was great to have you here. Yeah, at the end of the day, if we are all here that passion about planet, saving the planet, just making a world more sustainable, and sharing experience with everyone is key. And this is the key concept of Med-EcoSuRe, sharing experience not just inside countries, across borders. So it's great to see people from multiple countries joining this call. Just for us at here in Solartis, it's a true pleasure to be the ones organizing this session today. So I know there's going to be a super interesting content. Probably the most boring content is my introduction, so I'll keep it very short. Welcome everyone who is on GVC. Yeah, I'll just pass the mic to Med-EcoSuRe. Marco, Ines, again, thank you so much. Yeah, you can just tell us more about the project, and thank you, everyone.
Thank you. A short presentation of Med-EcoSuRe, who is the leader of the project. Si me permiten, voy a hacerla en español. Soy italiano, pero me encanta España en general. Hablo bastante más, hace mucho tiempo que no hablo español, pero intentaré hacerlo. Muchas gracias en particular a Jordi Muchas gracias a las universidades que son presentes aquí, a profesor Molina y Antonella Trombadori. No están con nosotros las dos otras universidades que son partners del proyecto. Quiero decir que no está la Universidad de ENIT de Túnez y no está la universidad con nosotros, la Universidad de Palestina, Najah, porque hoy es un día de fiesta para nuestros amigos y hermanos árabes y musulmanes. Es el día del Eid, es una fiesta muy importante y la celebramos aquí en Barcelona. Med-EcoSuRe es una muy... intento presentaros el Med-EcoSuRe, que es líder del proyecto, de forma muy breve. Es una plataforma de cooperación en las materias de desarrollo sostenible y energías renovables. Está en Túnez. Nació en el 2004 y nació sobre la base de un acuerdo entre el Ministerio del Medio Ambiente italiano y el Ministerio de la Industria y Energía tunecina. Participan en la plataforma de cooperación las agencias de las energías renovables del norte de África. Es una plataforma que se concentra en particular en el Mediterráneo occidental. Y es una plataforma de colaboración también entre universidad y industriales. Y en este sentido, el proyecto Med-EcoSuRe hace esta misma tarea, hace eso, se concentra sobre eso. Tenemos un comitado científico que regrupa muchas universidades del norte y del sur del Mediterráneo. Y puedo decir que nuestras características son, bueno, no gracias a mí claramente, pero decimos que somos dinámicos, es el dinamismo. Intentamos hacer proyectos en los cuales trabajan las instituciones públicas, pero somos constituidos en una forma privada. Quiero decir que somos el brazo operativo de instituciones públicas y intentamos hacer de forma más rápida cosas que quieren hacer las instituciones públicas, y intentamos construir una colaboración entre público y privado. Yo creo que bueno, he presentado más o menos, digo más o menos porque a causa de mi limitación lingüística. Pero bueno, yo creo que podemos empezar ahora mismo con Inés. Quiero agradecer muchísimo el trabajo de Inés y Suhe, que son el alma y el corazón del proyecto. Quiero agradecer la presencia también de Enea, de Nápoles, que está con nosotros, Nicola, y le doy la palabra a Inés para presentar el proyecto.
Muchas gracias.
Tu castellano es muy bueno, Marco.
Muchas gracias.
Muy bueno.
No es verdad, pero estoy muy contento con él.
Thanks, Marco.
Thank you so much.
So we will share the presentation. Thank you very much.
So I'm Ines Khalifa, the coordinator of Med-EcoSuRe. I'm really glad today to participate to this event, and I would like to thank the SOASIS team, and in particular Jordi, Letizia, and Yemi for the organization of this workshop. I will give a brief presentation. I don't know if the laser function. So yes, we will do it. We will do it manually.
I think it's.
I don't know. I will try. Oh, good. Thank you very much. So I will give a brief presentation on Med-EcoSuRe, sorry, and then give you an overview on the achievements of the project so far, before giving some insights on ongoing and future activities. So Med-EcoSuRe is the acronym of Mediterranean University as Catalyst for Eco-Sustainable Innovation. It is a project funded by the European Union under the ENI CDC program, the Cross-Border Cooperation Program in the Mediterranean. The project started 2 years ago, for a duration of 3 years, so one more year to go. And it has a budget a total budget around 3 million euros. It aims to propose and implement innovative and eco-sustainable innovation solutions in Mediterranean university buildings, and to introduce an active collaborating approach for decision support involved in the framework of a living lab. The partnership is led by Med-EcoSuRe, based in Tunis. It includes 4 universities, as said Marco, from Tunisia, Italy, Spain, and Palestine. And it also includes economic actors for results diffusion and technology transfer. And I name here ANEA and Solartis. So in addition to building a common understanding of Mediterranean university building renovation issues, the expected results of the project are reduced Mediterranean university building energy bill using energy efficiency measures and renewable energy applications, enhancing university occupancy and environment conditions, building capacities of energy managers in implementing retrofitting projects within universities, in particular, and within public buildings in general, and then highlighting the role of demonstration and leading by example of universities. So to meet these objectives, the project has identified a set of 6 outputs, mainly. These outputs are organized in working packages throughout the project lifetime, and they are strongly interconnected in the sense that we talk about outputs or realizations, actually, main realization of the project. So they're interconnected in the sense that the results of some outputs, of some realizations are serve as inputs in other realizations. So now, coming to the main achievements of the project so far, we first start by establishing a living lab, which is an intermediation entity for the collaboration between academics, decision makers, and stakeholders in order to support energy managers on planning and implementing innovative energy measures within university buildings. So basically, a living lab is, I don't know. So basically, living lab is a way for university researchers to conduct studies. I don't know why we have to move, sorry, to the next slide. Sorry. So it's a way for, yes, thank you very much. It's a way for researchers to conduct studies in vivo when based on experimentation and integration of research and innovation in real life situations. And the Living Lab, so it's a dynamic space where ideas and solutions are co-created in partnership with key stakeholders in real world environment. And so for our Living Lab management, we have already set an organizational structure in two levels: a strategic level for decision dedicated to decision making. It's a cross-border level actually, and another operational, so local level dedicated to the real implementation of solutions and technologies within the universities. We also identified technologies and the infrastructures to be tested and implemented within the Living Lab activities, and also we agreed on the methodology of collaboration between with the stakeholders and between the partners forming the Living Lab and within the community of the Living Lab. So simultaneously with the establishment of the Living Lab, energy audits have been performed in the 3 university pilot sites. I mean, in Tunisia, again, we have to move forward, sorry. Donc in Tunisia, at the National University School of Tunis, in Palestine, at the University of Niger, and in Italy at University of Florence. So the audits have led to a set of recommendations and the identification of opportunities of improving the energy performance of university buildings. Besides, we have identified, the partners have identified and selected a set of technologies to be implemented in real life, so in real environment, building universities. And the selection process has been supported by companies from associated to Solartis. So far, some equipments and plants have been already installed, such as a PV microgrid, PV powered microgrid in Tunis. Sorry, in Tunis, 160 PV plant in Niger, and monitoring system developed within the using the building information model in Florence. So some of the equipments have already been acquired and installed, whereas the tendering process is in progress for the acquisition of the remaining technologies, demonstration technologies, as well as the infrastructure work to be conducted within the university buildings. So one of the tools developed within the project framework is the toolkit of passive solutions designed for energy renovation of Mediterranean building universities, which is an interactive bottom-up and participative tool for best practices on energy retrofitting of universities, targeting mainly technicians and energy managers, as well as students as future professionals and decision makers. Professor Antonella will provide more details on this tool. Another decision support tool is the one developed by the University of Sevilla team. So it's a tool that enables energy managers to plan their renovation process within their universities. Again, Professor Molina will later provide more details on this decision aid tool. And then we are here. And finally, an online platform has been developed. I am in order to disseminate the best practices and capitalize on the project fundings, and also to gather the information among the partners and in collaboration with the stakeholders. So the Mediterranean stakeholders, from the different countries will have access to the platform and to the toolkits and the different tools that have been and will be developed in the framework of the project, as well as the best practices drawn throughout the renovation process in the pilot sites of Med-EcoSuRe. So as I said previously, we are at the second year of the project lifetime, and so far we have successfully we were able to successfully establish the Living Lab, develop a set of tools and decision aid tools for energy renovation. We performed the energy audits that led to a set of recommendations on pilot actions to be implemented. We have selected the innovative solutions to be tested, to be acquired and then tested in the university pilot sites. And during the last year of the project period, we will continue the implementation of the pilot actions, the pilot innovation actions, and which has already started in the first year of the project. And also we are foreseeing to elaborate strategic plan for Mediterranean University building energy renovation. So plans to be adapted for each local context, with the overall aim to convince the decision makers to adopt the solutions and the approaches developed within the project framework. So this is it for my presentation. I will then later give the floor to Suhe to give you more details on the training program we are also planning for the next months. Thank you again for organizing this event, and looking forward to welcome you in Tunis, I hope soon.
Thank you.
We'll love to go there.
Thank you, Inés, for your presentation. Now is the time to introduce the Med-EcoSuRe toolkits and training program. José Luis Molina will present the decision aid tool for energy efficiency retrofit planning in higher education buildings. José Luis,
Hello.
thank you. The floor is yours.
Hello. Thank you very much for the introduction and the organization of this event. Very difficult for face-to-face to be there, but your effort is not lower than otherwise. Well, I will show my screen with a presentation, and I hope this is running. I'm using a mixture of my home computer and my office computer. Then I hope not to confuse myself. Well, no. First, I have to share my screen. Sorry. I want to share this screen. Okay, compartir. Okay, and now Control L. Well, I prepared yesterday. This is the reason of this 19 June. Okay, 19 July. This is the old first slide. I'm very sorry, I couldn't change it. And the idea is that I will show briefly the progress of our main contribution to the project in these 2 years, almost 2 years, is WP4. And our main product, which is the toolkit for the energy renovation of buildings. I will comment the steps in WP4 from 4.1.5 to 4.1.8, and afterwards I will make a short tool demo, but it will be a live demonstration. I mean, I will connect to the server and start an example in the tool. Then, well, concerning the status of the development of the interactive tool, we think are by 95%. The end is foreseen for August of this year. So there are some we say in Spanish flecos still pending to be solved. And well, we are working on the calculation engine. You know, the tool is a user interface which is running in a web environment, and then the calculation engine for simulating the energy consumption and the saving given by the different energy conservation measures are calculation program, classical calculation C++ and Fortran programs, so very classic. And this is almost finished, and the connection between the interface and the program are almost finished, and this is the reason of 95%, and the date for the end of August. By the end of August, we are planning on having ready already a user manual and a few at minimum two examples for helping users to understand the running of the tool. We have a group of students. You know, we are in the university, so we have several final degree students using the tool just for checking possible bugs, which is very common in informative tools, you know. And there are 2 steps more in the WP4 package, which is the investigation of energy saving and financial cost of the selected renovation measure. We have a list of renovation measures. Antonella will show in a different way, more or less the same measures. And we have foresee to have it finished by September this year, but we have moved it to the end of December because of we had to prepare a lot of data, especially here you see in this text the lack of climatological data for a set of European climates. We can accept more climates during the running of the project. For instance, the climate from the north of Africa, we say in Spanish Oriente Medio, Palestine and so on, Palestine, and we could include more climate data. Then another interesting point is the buildings. We need buildings for being simulated when checking the interest of the renovation measure. Then I will suggest, I told yesterday to the coordination, I will suggest the partners to make examples using the tool when it is available, which is already, now it is already available. I suggest the partners to use the tool for creating a building which is a typical university building in their own countries. In such a way, we will have access to these additional buildings, which could be simulated in the different climates in order to obtain a database. And the results of this database will be used for preparing another product in the project, which is the guidance tool for getting the energy efficiency in, let's say, pre-calculated energy efficiency of the different renovation alternative in the different type of buildings in the different climates. And this will be a huge database which will be accessed by a simple tool preparing the Excel environment, and this will be given as a final product of the project. This is the climates already included in the project, and we are calculating all the cases. And here you can see a few preliminary results concerning the energy cooling energy needs and the distribution of the different calculations and so on according to the climatic severity index. The climatic severity index is higher when the climate is more hot, and so on. Then it's a good parameter for correlate the values. Then this calculation effort is almost 3/4 done, and will be finished by the end of the year, as I told you, together with the tool for accessing the results. The tool will be a simple user interface in which you will be able to select the type of building, the type of climate, the type of energy conservation measure, and see the set of records which has been calculated, just for you to see the range of energy saving or the range of money saving and so on. The result, this is more or less an advance. It's not necessarily the final format, but this is taken from an Excel tool now. Then everything will be finished more or less by the end of the year, and well, then the next steps will be a set of training for the stakeholders. And yesterday we were discussing about the possibility of making face-to-face training events or webinars. And well, we have to decide depending on the situation with the pandemic. But we are supposed to first to survive, second to be able to travel with this COVID-19 passport or whatever. Well, this is the idea more or less, and now I will start the demo of the tool. I sent to the coordination on September the 15th in 2020 a set of username and password for the partners. Then everybody has this username and password, and the server in which is running the software is tmt2us.s. It's a server in the university. And when you access that, you obtain this web page in which you see the button Med-EcoSuRe, and you click the button and you are given the access to the simulation engine. And let's finish this, and I will access. Now I have to move to my computer, my office computer. Okay, and I have here a session started. Well, at the beginning, you can see only these 3 buttons, and then you should click on open and select the case. I prepared a test which is called test JLM. I started this yesterday, and I thought it was better to have the case prepared and going around the different screens just for you to see the idea, the number of data that you have to give to the program for getting the information that we will produce at the end. Then the first are the general data. I have to say that for using this tool, you have to prepare the information. The tool will ask you for a geometrical and operational definition, which requires to study the building. Okay, then you will see the data, but you will also appreciate that there is some, let's say, cabinet work to be done before getting the hands on the tool. Well, first, the building general data are the area, the height, the year of construction. Depending on the year of construction, the user, the program has a database with the common thermal transmittances of the different building elements, as window, walls, roof, floors, etc. Then the number of flowers which are above the ground and below the ground, which is important for distributing the size of the building, and I mean the surface is divided by the number of floors in the building. In this case, I have selected just one. It's a flat building. Then, of course, the country. When selecting the country, you will see a list of all the European and Mediterranean countries from which we have climatic data. Then, depending on the country, you have region or province information. In Spain, we have logically all the regions in Spain, and in every region we have the different provinces and capital cities in which we have data. And then you can record here some data. And then the first work for the user is to introduce the building use. Here I have several type of use predefined, but we can see how it is done. Then the user interface has always this type of accessing methodology. You have a list from which you can select one, or you can add a new one. Okay, then let's select this. Then you say the different parts in which you can divide the building. We also prepare for the tool a list of common zones for a typical university building. See? Then you see, for instance, classrooms, common zones, dining room, emergency stair, kitchen, offices, etc. Then, for every one of these spaces, typical spaces, here, for example, I have selected common zones. You have to say which percentage of the building is occupied by this type of activity. Then, this is very simple. Building, I said 20% of the building is common zone and 80% are classrooms. Okay, but if you want, we can change this value. Okay, and define your own building. For every one of the activities, you have here the opportunity to say we are using which one of the 4 typical services: heating, cooling, domestic hot water, and lighting. Then, but this is a huge work, let's say, because of just with this simple name, behind this simple name are the definition of the occupancy activity, the occupants, lighting, and equipment, which is typically included in this type of zones in the buildings. Just for you to see how well with this, let's say let's create a new one. Let's say new test JLM, and then you see you have nothing yet. Then you put here a name that like UF1. This is a username, user selected name, and you can say this is a classroom, for instance, and you say this is 70%. Okay, and in the classrooms there is no domestic hot water. Okay, and you can add a new one, and you put here the second. This is a name, whatever, and then say, well, let's say meeting rooms, okay, and this is 10%, okay, and so on. Okay, when you have finished, you say okay, and going back to the previous screen, you will see the new functional description included in the list. Okay, and you can select the one you want, and there you have the surface. By the moment, you can only select one user functional definition, but as you have seen, this is a mixture of different type of activities. Then is much simpler for the user to select a single name here, which is divided in different proportion in the building. Okay, well, this is the definition of the general data. Once you have all introduced, click OK, and the program continuously saves the definition. Then if the connection is broken or whatever, you will not lose your work. Then I will go faster. The energy and economy aspects is important because you have here a list of energy vectors that can be used in the building with the pass factors to CO2 emission, primary total energy, primary non-renewable energy, and so on. And then the economy data, which is defined for the study with for the economical study, the typical economic data for the economic study, energy cost, and so on and so on. I suggest that you review all of this and say your opinion in case you miss something. Well, then the second more important description in the building are the reference energy consumption. Here I have different meters. This is very important. The user has to study the building because of they have to introduce the different meters. For instance, this counter of gas is defined for the energy source natural gas, and the list is the typical energy vectors, which is used for heating. Okay, and then you have to introduce for the different years that you have been studying in the audit, in the previous existence of the building, you have to introduce the energy consumption. We have simplified this very much, and we started with the monthly values, but at the end we prefer to introduce, just for making simpler the life of the user, the amount of energy consumption in kilowatt hours per year. Okay, but this is important. Is kilowatt hours used of in the vector natural gas for heating. Then the user has to prepare herself the distribution of the energy consumptions in the different services. Okay, this is very important, and this can be repeated for the different type of energy in the different services. You see, electricity for cooling, natural gas for domestic hot water, and electricity for light. Okay, the introduction of this is very simple. Is the same as before. You say here add, introduce a name, new counter, and when you introduce this new name, you can select it here and then say which type of energy source is used and which is the use of this. Okay, for instance, more cooling. Okay, then you have to add a new year in the period 2014-2020, and then select it and say which is the kilowatt hours per hour and the seasonal degree days for heating, for instance. Well, it's for heating or for cooling, but in
Sorry,
yes.
Sorry, Jose Luis, you have only 5 minutes left because we are.
Yes. I'm very fast now. Okay.
Thank you.
Then don't worry. But I have to stress these two sets of data because are very important. Now everything is much simpler. Then the building system is you have to go to the machine, to the hall of the machines for HVAC and see what is the equipment for heating, cooling, domestic hot water, and lighting. And for each of them with the same structure, you add a new component and then describe it below. For instance, the description is like that. You say all the which is the energy meter which is associated to this equipment, and then the nominal power, the capacity, auxiliary consumption, seasonal energy performance, and the fraction of the heating demand in this case that is covered by this equipment in such a way that you can have different equipment for the different services. Okay, the same as this, all of them. You see, well, I'm very fast now. You see, continuously you are getting feedback from the program. Then the geometry of contraction. This is also important and must be prepared in advance. And you have to say only the number of surfaces in the building envelope and the orientation or the roof or floor, and say how many square meters, the window percentage, and the thermal transmittances of the different elements. And these numbers are given by the program as a default value starting with the age of the building. Okay, then these are typical U values for in Spain national construction in the period after 2013. If someone of you have typical values for your own country, you can send us the values. Then the operating conditions. You have for every one of the type of activities defined for the university buildings, you have these days. You can select the type of activity among these 6 days. For instance, regular activity from 8 to 19, or extended split activity, or more wide, or whatever. Then regular. Then you are given the operating hours for heating and cooling services and then the occupancy, the maximum occupancy, this is square meter per person. It could be better to say the number of people, but this is a typical building energy efficiency procedure to say the number of square meter occupied by person. Then the percentage of this maximum occupation across all the hours, then the lighting, the equipment, and the percentage of use during the day, the consumption of water, and the set point temperature, and the distribution of the water consumption during the day. And this is the day, which is the type 1. This is very interesting because later you have to use the calendar. And in the calendar, you see the world year, the year starting always in Monday. Then during the year, you select the type of day, which is every one of them. You see, all the weekdays are type 1, and all the weekend days are type 6. You see, this is very simple. And I will give you a training opportunity. Then, once you have defined in such a way all the building, you go to the reference situation. You see file generated successfully. And this is very interesting because there is another machine in which we have the calculation. Look, this is 1957. Okay, this is just created, and the calculation engine is working for calculating that. As soon as it is calculated, you see it disappears, and you see here the results. Okay, the results are like that. Are the data set, original data set, and all the results. For instance, let me see this file. It's just for you to see, and you see here this is the results for energy needs, and this is the heating, cooling, lighting, equipment, and occupancy loads. Okay, and look, remember this number, which is 105,000 watts. Okay, then watts hour. Then when you go here, you can see the results. And concerning the raw energy from the 1 to the end of the year, for instance, let us see the heating needs. Okay, we can see all of them. For instance, always this, and say, okay, okay, and you see the hourly values. And just for you to see, you can select a period here. It's difficult. Okay. You see this number, 105,000, okay? The problem is that here, this is the reason of 95%. Here it says kilowatt hours, and it's watt hours, okay? Then this is a silly mistake. Then the idea is that you can explore the data and okay, I don't remember how to go back to this representation. You see heating and cooling, and you can mix more data. Well, these are the results in the baseline. Then we have the catalog. Then we can select, but this is very coincident with the Unify work, so it's more or less the same. And just for you to see the definition of the conservation measure concerning the opaque enclosure. Okay, you can select a name for the type of intervention, and then select the component in which you are going to make something. For instance, here I prepare a change in the roof insulation, which would change the initial value of the U transmittance from 0.5 to 0.3. Okay, and so on for the rest of the. And you can mix a lot of changes. You can deal with the thermal bridges and so on. Once you have defined all of these elements, also for windows, the ventilation and infiltration,
Sorry, Jose
night
Luis.
ventilation.
Sorry to interrupt you.
Tell me.
I think the presentation should be finishing now.
Okay.
We need to present the other toolkit and continue
Okay.
the agenda.
No problem. Well,
Sorry to interrupt you.
Well, it is just 5 minutes more, but I will not continue. Well, thank you very much. And a specific event on the training of this tool will be prepared for starting on September.
Definitely, we will do a training for this because it's not, half an hour is not enough to introduce to.
No, it's clear. But I wanted to show you a panoramic description of all the data. The idea is to make clear that the user has to prepare the data before getting hands on the tool. That's all.
Yeah.
Thank you.
Thank you very much. If any of you have a question, please write it down in the chat, and we will answer it later on in the debate and question and answers. Thank you. So we follow with the next presentation. It will be by UNIFI. Antonella is here representing University of Florence, and she will present the training, the toolkit of passive solutions design for higher education buildings retrofitting. Thank you, Antonella. The floor is yours.
Yes, thank you. Thank you very much. Let me share the screen. Could you see my screen?
Yes, we can.
Yeah.
Okay. It is really a pleasure to share with you the work in progress that we are developing in this period, in this phase, with the team of University of Florence. And our work is more focused on the development of a toolkit. And the vision of the toolkit is a very support system, no? In order to allow to follow all the steps to implement a retrofitting action in the university building. So as we mentioned before, we are in the framework of Med-EcoSuRe, and in our chapter, in our site in Florence, in the pilot project of Florence, we are implementing the MED-EcoSuRe. So to propose a very experimental site where it's possible to test the process, the toolkit, and all the different strategies to implement the university building. So it is an innovation process, and the toolkit is not only a methodology to be proposed, but it is a round table where it's possible to combine different experience and especially investigate the barriers that we have in all the different steps in order to cross over and to solve all the problem. So to do this, we are implementing and we are experimenting this tool in our MED-EcoSuRe. So in order to test the value and to test the real opportunity and the useful aspect of this tool. And we propose to share with all the partners in order to implement in the best way. Experimenting the tool in our site, it is not very easy because, as you know, the building is very old, protected by the law. So we are really investigate the different aspects in order to have a balance between the energy efficiency result with the introduction and architectural integration of different technologies, and overall to reach a very high comfort level in the indoor environmental. So we analyze our building starting from the history. As you know, it was a a prison, a convent. So the different functionality changed many times the layout of the building. It's characterized by two different courtyards. And our pilot is concentrated in this part. It is like a bridge from two different parts of the building, separating two different courtyards with a very good exposition. One facade is totally to the north and the other one is totally exposed to the south. Now this wing of the building will become the new entrance of the university space. So it is a very strategical location in order to create a place where it's possible for students, for teachers, and I hope for the citizen to test and to experiment a real pilot building where it's possible to see and to have a knowledge about the strategies, the technologies. So in order to become itself a training space and a research space following the real aim of the Living Lab. Now we closed the first phase. It was the geometrical analysis. It was the creation of a monitoring lab. So we set and we define a protocol, a monitoring protocol, and we organized this space with many instruments and tools to have a complete monitoring of the data about light, about thermal flow, about the occupancy. So to have a very complete framework of the real condition of the space. In parallel, we develop a digital twin of the space. So in order to compare the real monitoring process with the simulation that we can do in a tool. We are developing the digital twin, implementing with all the data. So not only the geometrical data, but it is in a BMI environmental. So it's possible to enrich the model with all the data. Especially about the performance of the envelope, the performance of the roof. So we are introducing many details about the performance of the wall. And it is very useful in the second phase where we compare with the different strategies and different materials and technological solution to be simulated. So it is the baseline where it's possible to analyze the opaque wall, the window, as you know, the different fitting, the system, the plan system, the artificial lighting. So all the elements characterize the environmental space and the quality, especially the quality of the indoor comforts. And now our work is implementing, analyze in a very deep way all the performance of the element. So another research about technical data to enrich the pilot, to enrich the digital twin of the pilot. And we are simulating the real conditions, so the light analysis, especially the light factor, in the real conditions. So in order to test the distribution of the light inside, in order to analyze where space is more comfortable than the other, and especially during the day. So it is not a one-shot simulation, but it's a dynamic simulation to create a virtual condition of the real space during all the day and analyzing all the data during a portion of time, so daily or weekly or non-monthly time. Many input about solar radiation, so the interaction between the external input of solar radiation and the energy and the temperature inside. Besides, we are starting to check and to evaluate different app and different software, and we are very pleased to test the toolkit of Professor Molinas as well. So in order to compare and to analyze which are the main element and the weight of the different element in the energy consumption. So we want to push in this direction, so to analyze the energy behavior, analyze the different input, the different characteristic. So in order to check where is possible to solve the problem in the best way. So analyzing the lower aspect in order to create a solution very targeted to our building. So we are analyzing, of course, the envelope, so the thermal energy conduction throughout the envelope and the thermal energy for irradiation, analyzing which component, so the impact on cooling and the impact of heating, and of course for the winter period and the summertime, and comparing with the data of the monitoring. The second step is the investigation of the different solutions. So to create the scenario in order to solve this aspect, implementing in a very balanced process. So our aim is to create a real sustainable balance between technology integration, the cost, and the performance. So we are working in a very strategical building, especially for the architectural aspect. So it is not possible to change of the envelope or to recreate a different architectural aspect of the building. But as a pilot project, we are proposing to our administration different methodology, especially methodology to obtain a very effective retrofitting solution. So this is the roadmap that we are shared with our administration. So starting the vision of the X-Lab-like experimentation site. So as I tried to explain before, really a pilot space, a pilot research space for students and for teachers and PhD. Of course, our aim is to implement the indoor environmental quality, proposing energy efficiency, but with a very pay attention for the integration in the historical context. This is very important because many university buildings are inside the historical building in the city center, not only in Florence, but in Italy, but I think in around Europe. So this is a very key question, how is possible to mix the new technology with the historical context. So our objective for pilot project is three main pillars. So comfort, energy efficiency, architectural constraint, and we select different quality indicator. Of course, to implement, to improve the indoor comfort, we are focused, we are very interested to implement the thermal benefit, so the passive and the active aspect, as well as the lighting, natural lighting improvement. About energy efficiency, of course, the reduction of energy needs, but the reduction of the cost of energy consumption. And the third one, it is very, very difficult. We are focusing about the reversibility. In the vision to create a research laboratory in a historical building, maybe this could be a very attractive solution. And of course, the feasibility. So the real effective opportunity to install the different technologies. We are creating 3 macro scenarios of the intervention. One is totally represented of the retrofitting of the envelope, so direct intervention on the envelope elements, so opaque as well as transparent component, by addition or by changing the actual technological solution. The other scenarios we named double skin, so creating, especially in the south facade, it is the more problematic aspect, an additional technology to integrate the solar control system, so like a shading device, in order to manage the solar radiation in summer condition as well as in the winter, implementing both the passive contribution, passive heat gain in the winter, as well as reducing the thermal storage, so implementing the passive cooling in the summer. The third one is the three-dimensional, so creating an external structure in order to preserve and to save the existing situation, especially from a point of view of static aspect, structural aspect. So it is an independent solution, but the benefit will be obtained in our building. So working in a combination of benefits starting from another structure outside the building. So working in the very near microclimate condition of the building. Of course, we have to manage and to balance two different targets. One, the target is to reach the high energy efficiency level, and the other one is to reach the better integration in the historical context. So we are now exploring the break-even point of this double target to be reached. In the first macro scenario about envelope, we are investigating especially three main aspects, three main technology. So thermal insulation of the opaque wall, especially point the accent in the external insulation or maybe internal. So we are evaluating both the solution, the fixture substitution, especially smart window or double glasses, and more high technological solution to reduce the thermal gain, and especially the solar radiation control, so to manage in the different season, the heat gain coming from solar energy. And we, of course, we are analyzing the different benefits starting from this kind of solution and comparing, of course, the energy reduction, but comparing the feasibility of the structure and the different benefits, especially in the implementing the wall conduction, because we are more working on opaque wall and in the envelope performance. The other one, so we are analyzing each benefit, the benefits from each technology, and we are trying to analyze in percentage how many energy is possible to reduce it with the technological mix in the envelope. So many scenario, many analysis of this, and I go faster to show you the architectural solution of this, especially with the first project is about the skylight. So we are investigating the opportunity to create in the roof a skylight in order to not only to manage the daylighting inside, to have an homogeneous distribution of the natural daylighting inside, but to integrate the fitting in the plan inside the roof. So we are moving both with the simulation, with the analysis in the real site and the digital twin, so comparing the different mix. Many scenario, many architectural solution to analyze the concept. So about the double skin, we start from the very easy solution. So it is a very easy structure outside the building to have a shading, to introduce a shading device and maybe to implement this with a photovoltaic, so maybe a double glass photovoltaic, so to have both solar control and production throughout the solar radiation, and investigate different architectural solutions. So replicate the idea of portico, replicate the idea of the distribution of the typology of Florence building in the new structure. So many, as you can see, many architectural concept with different material and especially with different feasibility level, investigate the mix of the material performance, so the use of steel, the use of wood, so how each material could contribute in the similar architectural scenario, implementing the comfort inside. So based on the similar architectural layout, changing the performance of material, the color of material, the capacity to transmit the heat, and of course to replace the daylight inside. So many simulation. This, and another point is the opportunity to investigate the opportunity to have a green integration, especially with plant containers. So using the plant as a new natural technology, natural-based solution, we implement the comfort inside. So the idea is to create a new facade, like an external extension of this research laboratory, experimenting the different section, different technologies, so to monitoring and test different solutions. Another one, more attractive, more design, is focalized about the horizontal shading device, analyzing the effect of the lighting, especially in the first floor, because it's very dark. So analyzing the reflection, so the tilt of the solar radiation, the reflection inside. So as you can see, we work both with external view and the internal, the simulation of the internal space to control everything. The last one is a 3D, so creating a new external space, maybe useful for students to spend their time outside the building, because there is another needs to extend this space outside. Combining both the integration of energy production, the integration of greenery inside, and a structure combining the architectural aspect of the old portic. Different version of this idea of external structure, experimenting different material, different solution. This is some some solution about perforated steel element as well as with different texture or aluminum or other element, or maybe combining the green integration with climbing plants. So another one is different concepts, so an outstanding, self-standing structure outside the building, like a tree, like vegetation outside, so to create a microclimate, a new microclimate. It is last scenarios analyzing how it's possible to solve the problem inside the building working outside. So it is a borderline solution, but I think it's very useful to investigate this other aspect, especially in existing buildings, especially where it's possible to have a garden outside or many space outside. So in this structure is possible as well to integrate not only shading device for solar radiation, but maybe it's possible to integrate plan as well as PV panel. And this kind of structures we are analyzed to develop in another concept like a 3D structure, maybe integrate much more plant, much more greenery, and transforming the garden in a pergola, no, as a pergola, implementing the outside space, so combining the microclimate.
Sorry to interrupt you. You should be ending the presentation shortly.
Yes, I'm finished. And this is the last, the last slide. Just to explain, yes, that our work is ongoing, is process, and now after all the evaluation, we are analyze and evaluate which is the more suitable solution. So thank you very much.
Thank you, Antonella, for your presentation. So now that we are going a little bit late, we will introduce the training and dissemination program to capitalize on the project results. The objective of this training will be to lay out the innovative renovation technologies and solutions offered and emerging from the Living Lab. So for the matter, Ms. Soha will explain a little bit more about the content, the time frame, target audience.
Just we have one slide in the presentation of Ines. It's the last slide. Is that?
Just 1 second.
So we go straight to the last one. So in the meantime, I introduce myself again to the new participants. I am Sunay Bushishi, a member of the Med-EcoSuRe coordination team, which is from the Victorian Energy Center. So if I may just, before starting presenting the training program, I would really like to thank all the project partners and stakeholders that we have been involving, including the companies that are present with us today. And actually, thanks to this collaboration and cooperation, I would like to highlight that we have been selected as one of the few success cases within not only the ENI-CBC project, but also within the ENI-CBC, which is the European Neighborhood Instrument cross-border cooperation. And this actually has been shown through the positive evaluation of our progress and intermediate reports, where we have been, or we have obtained the highest marks, and also by being featured in a thematic publication of environment, which has been published by the ENICBC program as a project targeting climate mitigation and adaptation in the Mediterranean region. So we are really, really proud of this achievement, let's say, because we have been working on a very promising, ambitious, and also a challenging project. And when I say challenging, I mean, of course, part of it is due to the pandemic, but also it's because we are dealing with public universities, and in some cases with historical universities. And we know that it is not very easy to deal with this type of universities and to plan and implement innovation actions. And so, yes, it has been very challenging, but of course, thanks to, let's say, very highly qualified consortium and also stakeholders that have been working with us and actively involved in the project, we have come this far. And I hope we continue to work, let's say, with the same enthusiasm in order to reach our final goal, which is actually to provide decision makers in the Mediterranean with action plans enabling them to plan the energy renovation of their university buildings, which also can be extended to public buildings. So this was the communication and promotion of our project. Now,
You should celebrate that.
Thank you very much.
Congratulations all.
So now the training. So in the framework of our project, we are actually going to organize a number of training and capacity building programs in order to capitalize on the thank you very much. In order to capitalize on the project outputs and results. So the scope of the training, as Yemi mentioned, is to lay out actually the emerging technologies and solutions that we have been developing within our living lab and with the collaboration of project partners as well as stakeholders. So the target group actually of these training sessions or programs will be depending on the content of each phase. Let's say it will be dedicated to energy managers, decision makers, academic staff in the university, students, socioeconomic operators, so etc. So far, we have identified 4 phases, let's say, for our training program, depending or each one is dedicated either to one toolkit developed or one facility installed. So, for example, we will be conducting training sessions targeting the energy managers and decision makers within the universities on how to use the Decision Act tool that has been presented by University of Sevilla right now. And this training will be developed and conducted by University of Sevilla in collaboration with Solartis team. Also, we foresee to organize training sessions on the passive toolkit design, the passive solution design toolkit that has been presented by University of Florence right now, and a training or workshops, let's say, on the design, installation, operation, and financing of renewable energy technologies. That will be conducted by Najah University. So actually, the university has already conducted a training program, including conferences, practical workshops, and site visits on the PV power plants that has been implemented in the framework of our project. And we think that it will be very relevant to also organize more trainings on the innovative technologies that will be implemented in the very soon future in our project. Finally, we will be organizing an autumn school on the design, installation, operation, and financing of microgrids. So in our project also we have installed a pilot installation, which is a microgrid platform for energy generation and trading. And so we are going to organize in this fall an autumn school on how to design, install, and most importantly to finance these microgrid platforms. So far, these are the trainings that we have identified, but of course, other training programs may emerge depending on the activity's progress. And I would like also to take this opportunity to invite all the also the companies that we have today here with us. If you are interested, of course, you can also propose and conduct trainings on the solutions that you have proposed in the framework of our projects in order to train especially the energy managers and technicians who will be the ones in charge of installing and monitoring the building in each in pilot university of our in the framework of our project. So we will be publishing more details on our project website with the dates, the final dates, of course, of the trainings and registration forms for people who are interested to join our training program and benefit from the best practices and results of the project. So this is it. Thank you.
Thank you very much for explaining the training. I think it's very interesting for all of us. And I hope you find it interesting as well.
Yeah, sure.
So now we go for the coffee break, but before that, I will kindly ask you to turn on the camera to take a picture, if you want, of course. And here as well is also Marta, who will take in the pictures, so you want to.
So should we be close to the screen or how?
Yeah. Go.
Because keeping some distance, but close to.
Just a second.
We should start presenting.
Okay, cámara Isabel. José, César, Andrés.
Yeah, should come to the screen and trying to keep distance to each other.
Take the picture.
We're going to the screen.
Someone did.
So I guess Nicola, yeah. Nicola, Jose, Antonella. So I guess that's a no.
Keep your cameras open, please. Just a second. One. Understood. Thank you. Thank you very much.
So we'll come back in 15 minutes. Thank you.
Where is the coffee break, please?
I will send you the coffee and the pastries.
Okay, see you in 15 minutes.
Welcome back, everyone. Now, we have finished now the coffee break. We'll wait just 1 minute for you to come back. And then we will start with the presentation, and the third part of the meeting, of the awareness raising event, will be the process of identification and innovative emerging technologies from high performance building renovation that we organized with the University of Seville.
Okay. Hi everyone, I'm Leticia Gomez, the cluster manager of Solartis. I'm physically in the office, but also online, so you can see me in both places. We are presenting, yeah, there is. Okay, here my presentation. So I'm explaining the process of identification of these innovative solutions that after my presentation, the companies, they will present. So I will be really brief because I think the most important part of this event is the companies explaining their solution. So first of all, doesn't work the, no, the command. So if you can, yeah, the first, okay, the objective of the process was to prospect this solution, innovative solution, related to energy retrofitting of university buildings. Okay, so we do a process. Slide.
Someone has the microphone open, so please
Close the microphone. Can we close the microphone? Okay, I think now
It's off now.
Now it's off. Okay, so to identify these innovative solutions, we did 3 main steps. The first step was the creation of a data sheet to fill by the companies. After filling this data, we did a call for solutions through different channels like social media or emails. And with all the data selected, we evaluated with the University of Sevilla all this information, and we selected the most innovative solution through 5 main criteria. Okay, so it's University of Sevilla, they created a committee of experts. So was a process and a work done by experts of the material. Next one. Okay, this is an example of the data sheet. Is a template where you can see all the areas that can apply to the efficiency building improvement, like lighting, domotics and smart solution, heating and cooling, facade isolation, and new materials, energy efficiency, solar energy, energy storage, and others. Okay, the good point, and we will see that we received all the solutions that we received applied in all these areas. So we received a solution for every area of this area of work. So next one. With all this information, after the call, we launched a call to receive all this information. We organize all this information and we work with the University of Sevilla, evaluating the solutions through 5 criteria that we will see in the next one. As I said before, we received 18 innovative solutions that applied in every area. Like lighting, we received 1 solution. In domotics and smart solutions, 4. In heating and cooling, 1. In facade isolation and new materials, another 1. About energy efficiency, 4. Solar energy, 8. Energy storage, 2, and others were from thermal energy. Next one. This evaluation, as I said, was using 5 criteria. The first one was evaluating the innovation level of this solution, comparing with other solutions in the market. Okay, so with this criteria, you can see which solution is more innovative, and you can apply that in the buildings, especially in the university buildings. The criteria 2 is evaluating about the impact of the solution at the local level. Okay, we are working together different regions, so it's important to analyze the impact in a local level. The other criteria is how well the solution addresses the needs of the building. If they are improving the efficiency energy in this building. Another one is to improve the collaboration at the transnational level. We are here with the Tunisia team, and we're working with other partners from Palestine, for example, and Italy. So it's important to analyze if this solution improves this collaboration between the partners. And the last one is about the price. We have a maximum price. So it's important to apply solutions that it's not the cheapest solution, but it's important to analyze how much costs the solution. Next one. Okay, the evaluation of the solutions after the committee of the experts analyzed these criteria, we wanted to expand the evaluation to the rest of the partners, doing more democratic this evaluation. So after we have the opinion of the experts, we want to know the opinion of the rest of the partners. So we open a drive with all the solutions, 18 solutions, and the rest of the partners could to analyze these solutions. And they made an opinion. And after this evaluation altogether, next one, we have some of the winners. And here, fortunately, we have some of the notable contributors. There are 4 companies here today representing their solutions. Some of them, they won this process. They were selected as the most innovative solutions applied to the efficiency buildings. One of them is NDEF Engineering, who is connected online. Trama Tecnoambiental, who are here physically with us, Marilena and Xavier. Ingenium is Andres, connected online, who couldn't to stay here with us, but he's with us online. And Sun Solutions also here physically, Maria. So after this presentation, they will present their solution, and we will know these innovative solutions applied to the market. So before to finish, I will share with you that the conclusion is that there are a lot of innovative solutions that could be applied to the market, and it's important to share this knowledge to the region, like here today through this project and other projects, because it's important to improve the efficiency, energy efficiency in buildings like universities, but also in other public buildings. So for me, it's a pleasure to listen today your solutions, and I hope to see this solution in the market applying to the different buildings. So thank you very much for listening to me, for attending today the event. So Isabel.
Thank you. Thank you very much, Leticia, for the presentation.
Thank you.
We were in the process, during this process, so we had to figure out, and like we are sure that it was this way, and you probably know the companies that are here represented and the ones that are here face to face will know that is the process followed. Thank you very much for the explanation. So now Isabel is representing NDEF. You will present the NDEF solution.
Okay. Can you hear me?
Yeah. Yes.
Okay. I'm going to share my screen. Okay. Okay, can you see my screen?
Yes.
Okay, perfect. Well, good morning. I'm Isabel, the CEO and co-founder of Endef Solar Solutions. And well, we are a small company located in Zaragoza. We were founded in 2012, and our mission is just to make possible the independence of the people thanks to the sun. We also are also a very small company, but with a high level of innovation. In fact, we have several PhD in our company. That is not quite common if you see another small companies. And we work very hard in doing innovation and moving this innovation into the market. Okay, we have 5 different areas. We have a research area, of course. We also have an engineering area, the manufacturing area, the installation, and the monitoring. So that way, like, we are working in different areas, and we are able to have information of in the field what is happening, and also continue improving always. Now I'm going to present the solutions that we have present in this project. In our world, we have a problem that is that our buildings and our houses have a high consumption, and we are not able to produce all the energy that we need with solar or with PV panels, because the efficiency, I mean, is low, is quite good. We can see like 20% of efficiency, but it's not high enough to cover all the consumptions that we have in our buildings, okay? We can see the consumptions of our buildings in Europe are quite high. Also, if we see the heating and cooling part is a critical consumption that is difficult to cover with solar energy. So for that reason, Endef in 2012 developed a hybrid solutions that produce heat and electricity in a single panel. And that way we can just reduce the area that we need to produce more energy in our houses. Okay, so we have like 2 models with water. One is patented and another one no. One is a glazed model that produces more heat and not too much electricity, and another model is an eco-wall that is a glazed model that this one produce more electricity and less heat. So depending on the energy that you need, you can use one or another one. And for that, this project, we have presented a new hybrid solar panel that we are developing that we call EcoAir. In this case, we don't use water as fluid, we use air. And we try to produce electricity and heat, but for heating, not for water, okay? So that is the main difference. Here you can see that we take the sun, okay? We can produce around 20% of electricity, and the rest, the PV panel is going to just liberate as heat. So we are going to try to recover part of this heat with air and to use it for heating, okay? And this is our panel. This one is also patented because we have designed a symmetric absorber that is located in the back part. And with this panel, we can use it in winter for the electricity, space heating, also ventilation and purification of the air, and in summer to cool down also the ambient during the night, okay? And also, of course, electricity, ventilation, and purification. And this is how it works. We put several EcoAir panels together, and we just need a ventilation box that is where the fan is located, okay? And we can just introduce the air into the building if we need it, or we just can evacuate it if we don't need it, because, for example, it's summer and we don't need more heat inside. We also have this all on the cloud, so you can just see how it's working, the installation, and also change the configuration if you need it, okay? These are the main parameters of our solution. is that we can achieve temperatures up to 55 degrees. This is the thermal power, it's around 680 watts. And the electrical power is quite good, it's 400 watts. Sorry, it's
Keep going.
because it's the first EcoAir that is based on half-cell PV mode. So we are using air as fluid, but we are also using like a PV technology that for the moment the PVT market has not used until now, okay? And we also have some advantages if we take into consideration the mounting system. We can install in new and existing buildings. We also can use flat and sloping rooftops, and it's like very scalable, like the PV panels, okay, for large or small installations. You can see here how it's working, like in winter, as I have already mentioned, just to produce electricity, heat generation, and the ventilation. In summer, we can just evacuate the air, and we can use it for cooling during the night if we want it, okay? So the main advantages that we have with this panel are that we can achieve high temperature with air. That is something that is not very usual. We can just install in new and existing buildings, and the payback is very low. Right now we have one demo in 5 panels, EcoAir panels in offices, and here we can just see the first results. These installations start working in April, so we don't need like heating all the days. For that reason, we have some days that we can see like the PV generation, that is the red line, and the blue only when we need it, okay? And now we are carrying out another demo in an industry with 80 EcoAir panels that we are going to be able to heat the work space of the people that right now they don't have a heating system there. So this winter we will see the first results of this installation. And this is everything. If you have any questions, yes, I will be happy to answer.
Thank you, Isabel, for your presentation. If you have a question, please write it down in the chat, and we will answer it later on in the debate and question and answers. Okay, and here as well for you, we will discuss about this later. The next presentation is Marilena Lazopoulou from DTA, Drama Tecnoambiental. Thank you, Marilena, for coming. We will share now the presentation.
¿Tengo que usar un botón aquí?
No. Are you sí, what we want now firstly, Gracias.
So good morning to everyone from my side. My name is Marilena Lazopoulou. First of all, we're very glad to win this small competition of innovative solutions and be here with you to present the solution. First I'll give a quick glance of the company, present our services, and then actually took the liberty and add another innovative project that is very relevant to Med-EcoSuRe for reasons that we'll see later, and present you the actual project that we had to fill in the form for. One is PV installed in public institutions that are connected in weak grids that have a lot of blackouts, and the other one is PV for autonomous institutions. So it's quite different from what we have seen so far. No?
It's not full screen. No.
But for people on DC, is otherwise.
Yeah, we just figured out that.
Thank you. So Trama Tecnoambiental is a consulting company with more than 35 years of experience in the world of renewable energy, especially energy for access. So with this experience we have from as consultants for different kinds of clients, but also from our hands-on experience on the ground from installing plants. We can provide like very innovative services to our clients, which are, for now we have worked to more than 55 countries around the globe, especially in the emerging economies. So we focus on 3 areas of expertise. First, we do mainly PV projects, but also with other sources, renewable energy sources, for distributed generation through mini grids or grid connected systems. Then we work on energy efficiency and also sustainable building projects. So we provide a wide range of services. We are consultants for multilateral agencies, all relevant stakeholders on renewable energy, also private companies or governments. Then we have a knowledge hub, what we call, to provide specialized training services to different kinds of stakeholders, including installers or governmental officials. And also we organize international conferences, which in the last two editions are being held in Mallorca. Then we are contractors, and we do EPC work, or we act as owners engineers to gain even more hands-on knowledge on the systems. And then we have a department for innovation projects, including development of products, also participation in EU-funded projects like Horizon 2020 or other research and development activities. Back in 2013 to 15, we participated in a project called Med-EcoSuRe, which is actually one of the previous projects of Med-EcoSuRe. It's quite connected because in the big consortium that we had, one of the partners was the University of Palestine, and we like previously collaborated with Professor Imad, who unfortunately is not today connected. So this project actually had 3 pilot projects, one in Palestine, one in Jordan, and another in Lebanon. We provided, apart from coordinating the project, we provided technical assistance for the realization of the PV plants, which were interconnected to weak grids. So grids that suffer with a lot of blackouts, and during the blackouts they need diesel gensets to provide the supply with energy when the grid fails. So we created an energy management system, which was basically a genset controller to be able for the PV plants to switch between the grid or the main grid or the genset grid and provide different functionalities. So the first pilot there was at National University Hospital. It comprised of a PV plant of 140 kilowatts. So it's previously the one that installed with the Med-EcoSuRe project. And the actual functionalities of this PV plant was to provide peak shaving. So the energy controller was able to provide peak shaving when there was grid. And when there were blackouts, the PV was used for fuel reduction as a fuel safe means. Then in Lebanon, we installed PV on a market, the MCAN market. And in this case, The PV was used to electrify as a UPS, so uninterruptible power supply, some critical loads like cold storage, and also do fuel reduction and also net metering, which in Lebanon at that point was permitted when the grid was present. The third pilot was in Jordan, in another university building. It was comprised of a plant of 80 kilowatts, and the functionality there was also to do peak shaving when the grid was available, or fuel reduction when the university was run by the diesel gensets. On all those three plants, they also had storage to complement the PV generator. So the other innovative project to present, which was actually what was filled in the form by us, it's a kind of different concept. This is a PV integrated in an autonomous building. So this solution was proved already after being installed in 15 clinics in Ghana in a project funded by USAID. So that was not to support the grid or do energy efficiency, but actually electrify this building. So a standalone PV plant. So we designed a kit of a PV array of 3.5 kilowatts on the rooftops of the institutions, of the clinics. They were 100% solar. They didn't have any backup. So the innovation here was actually to share the limited amount of energy among the different users. So the clinics actually did not only have the clinic, but also the houses of the staff, of the doctors and the nurses. So this through adding some smart meters, actually advanced meters, we managed to split the energy among the different users equally, according to actually their needs. The most important criteria of this installation, since it was in a very remote locations in Ghana, was to be very easy to transport and to maintain. So we ended up with this solution. You can see the center of the single line diagram, and on the right, the actual interior, so the kit, including the PV, so the charge controllers, the battery inverters, and the actual batteries. It's this coupled system. It only took 1 day to install and to train the users and the staff that was responsible for maintenance then of the plants. But actually required very little or no maintenance. We put non-spillable lead acid batteries, closed ones, sealed ones, so no maintenance needed for the batteries, just some cleaning of the PV modules. So this kit provides energy of between 8 and 11 kilowatt hours each day, and it has also a storage component of 31 kilowatt hours. And in terms of operational aspects, so sharing energy is possible through those meters that you can see on the top picture, which this meter is called an electricity dispenser, and each end user had one installed and configured already the energy limitation, the daily energy limitation. So we created for basic support a WhatsApp group between the 15 clinics and us, just to help them with first maintenance tasks in the first years. And actually after the first 24 months, we could confirm that all 15 systems were working properly. and just some, because of people sometimes connected some loads which were not taken into account when we designed the system. So they were not appropriate, so we had to disconnect those loads in order to be able to have like, autonomy to the systems. For this in type of intervention, we start with assessing the needs of the building, whether it's an institution or maybe some commercial user or a whole village. Then we proceeded with the engineering, with the procurement, the construction, and also the training and O&M support of the technicians there. And you can see briefly a list of the main components of this innovative solution. So this kit, which is 3.5 kilowatts of PV. So the rooftop mounting structure, the battery inverter, the charge controller, the batteries, these two electricity dispensers, one for the clinics and one for the houses, and then all protections, earthing, cabling, and accessories. This is, for a low budget intervention. Well, thank you very much.
Thank you very much, Marilena, for your intervention. I think it's very interesting. It's something very interesting, everything that you have done. So congratulations on that. Next presentation is from Ingenium. Andres Sornia is here representing Ingenium. Andres?
Hello, do you hear me?
Sorry, no.
Low.
Yeah, really low.
Really low. Okay, let me. It's better now?
Yeah,
Yeah,
Okay. Have problem with the microphone. Okay. So let me share the screen to show you the presentation. This one. Let me. Sorry. Okay. Do you see the presentation?
Yes.
Yeah, we can.
Okay. So, well, I'm from Ingenium. It's the company name. And well, since 1998, we have been designing, developing, and manufacturing here in Spain, in the north of Spain, in a region called Asturias, automation products. I mean, products for home automation. We start with the home automation, and then we move to bigger projects. Of course, that requires a very high R&D investment. And well, we have our own communication protocol, and we also work with other different protocols for automation, for building automation. The objective of the company is to make home automation accessible for everyone. Okay, so well, we make very safe and robust devices, easy to install, cheap, and well, the most important thing, very easy to configure. Well, as I told you, we start with the housing, with the house automation, but then we start moving to bigger projects. And well, we now are working in hospitals, in hotels, in very big buildings. We have not yet make any project in a university, but we have similar buildings like public buildings and that kind of buildings. So it's almost the same. And well, in our solution, we have wired devices and wireless devices. For the wired devices, we work with two protocols. One is called busing, that is our own protocol. And we also work with KNX, that is the standard protocol for building automation in Europe. So we have products that works with both protocols. And then we have a wireless protocol with wireless devices that is called WINGS. So, well, of course, the wired devices are more for new buildings, and for already existing buildings, the wireless devices are better to avoid problems with the wiring and the installation. And well, our devices control lighting, control blinds, climate, alarms. We can manage all the systems that we have in a building, and we can manage the systems to save energy. For example, with the lighting, with sensors that only turn on the light if you are in the room, or the sensors that keep a light level in a room. So if you have enough light in the room, you will not need to turn on the light. If the sensor detects that there isn't enough light, it will not turn on the light, or it can also dim the light to have a light level. And of course, that saves a lot of energy. With the blinds, you can play with the blinds to have more light in the rooms, or also to avoid the solar heating, to make easier to cool the room. With the climate, you can, depending on the hour of the day, you can put one temperature or other temperature. Everything managed from an application, or from your computer, your mobile phone, or well, any device that you want. And we have a very complete range of products to develop all these functions, to control all these systems, the lighting system, the climate, and everything in the buildings. And we have our own mobile app and computer program to manage all the products, to manage all the system. Or we can also do all this controlling of the system with the Google Home app, or the Alexa, the Amazon Alexa app. So, well, three options: our app, our program, the Google Home app, or the Amazon app. And then, well, with the products, we can control all the system. And of course, we can also take data from the system. We can take the data of consumption. We can take, well, the data of what is happening in the building. And knowing all this data, we can take decisions. We can program decisions in the system to work automatically. So, for example, we can say if the consumption is greater than I don't know 1,000 kilowatts, we need to turn off the heating system. Or so, depending on the data that we are taking from the system, we can program decisions, and the system will take the decisions automatically. So, well, that provides a big energy saving. And well, now in the company, we are like going one step further, and we are starting with the smart city project. And well, the smart city projects are projects in which we take all this knowledge that we have in the buildings, and we go one step further and develop all these functions, not only for a building. We do it for the whole city. So we take the data for from all the buildings. We manage all also the street lights, the consumption of the street lights, and with all this information, we send orders to the different devices installed in the buildings and also in the city. And well, save energy not only in a building, we do it for the whole city. Well, thanks for your attention, and there is my my mail and my phone. So if you need something from my side, it will be a pleasure to answer you and to help you.
Thank you, Andres, for your presentation. Sure, we will have some questions after during the debate and answering questions. Thank you very much. Last but not least is the presentation from Sun Solutions. Maria Lopez is here representing Sun Solutions, as she is the CEO. Welcome, Maria, and thank you for coming today.
Can I add a website link?
Yeah, he needs to be here controlling the presentation.
Vale, sí, voy mejor.
That 1 second.
¿No es what?
Sí. Si no, pues And you want to share the screen?
Yes. But it's sharing.
No, but nothing online.
Oh.
We are sharing the screen. Just a second. Okay.
El micro. Hello, I am Maria from Sun Solutions PV Energy. I'm managing the company. So we are a little company founded in 2008. And the principal area we work in the start was the developing and promoting solar parks, photovoltaic solar parks, to sell the electricity in the grid. So our main work is producing electricity from renewable energy sources, mainly photovoltaics, based in photovoltaics. We own 2 solar parks selling this electricity to the grid here in Spain, one of 47 kilowatts and one of 1 megawatt, no? But this is in the starting, we were doing that. After this, we work in the area of distribution, selling materials, mainly for photovoltaics, and with the characteristic of trying to offer to clients the best solutions and more quality in the market. No, we select the best products who are offering the best quality, design and warranty and have the best life over the years, no? Because the solar photovoltaic solution is not only for the right now moment. All these systems need to have quality in the scope of years, no? So we try to offer these best materials, no, after our study in the market. The other area we work is solar system installer, here in Spain mainly, also in other countries as France. In the south of France, we developed some projects for residential. I show you some systems here. We introduced here in Catalonia the lithium batteries in the solar residential projects, no? Using lithium batteries for safe and for make more efficient the system and the consumption of the clients, because here in Spain the electricity bill is a high cost, no? I don't know in other countries, but here it's a lot of expensive, and with the lithium batteries you have a very good solution to save money in your electricity bill in your house, no? Also, we are here today because we believe we can offer a very good solution to the buildings, to the public buildings in the frame of this project, no? The solution we are offering is the Onyx solar PV glass, which is a photovoltaic glass to be integrated in buildings. I need to move la presentación, la que yo mandé.
Okay, we are sharing the other presentation
of the material. Okay.
Okay, we are sharing.
Okay.
No.
You're not sharing your screen.
Okay.
Bottom left. Bottom left.
Okay.
Ah, here. Thank you. I was looking for the presentation. Now you are sharing. Okay, perfect. Okay.
Yes, with this technology, photovoltaic glass, you can have a solar generator system in your building, and you can switch this special glass to the needs of the building. No, you can use in the wall. You can use as a curtain to separate spaces. You can use as a you can use as a as a roof, or as a floor also. And
yes.
Okay, pero
No.
puedo mover. ¿Cómo
Yeah.
puedo mover?
Sí.
Con...
Si le das un clic, se mueve.
Vale, para atrás. Ponen aquí atrás.
O si no, las flechas.
Vale.
Con las flechas puedes.
You can use in the way you need in your building, so you only need to study your needs of consumption in the building, or to detect what is the focus you want to use this glass to produce energy, also to avoid the sun entering in the area with asking to the manufacturer to say to ask how many cells I want in the area in the square meter I need to protect or not of the sun some area. No, you can design as you want the glass. No. And this glass have a lot of good properties. So the one is energy generation. You have a generator of energy in your building. You have a filter of sun, so you can use as a isolation. In countries as Tunisia or Palestine, in these countries we have a lot of sun in every month of the year. So to have a filter in your wall that in the same way is a generation energy of production is you have two things in one material. Also is, as I am saying, thermal and acoustic isolation, no? You have the natural illumination is available in the curtains. You can decide the level of shadow you want or not, no? You also can ask for color of cells, percentage of cells in the square meter area. So it's very flexible material and very innovating, no? This glass is done with amorphous cells. It's a specific type of cells, photovoltaic cells, who have a type of efficient, or crystal silicon is the similar to the standard solar panels in the market. No? This solution is very aesthetic, as you can see in the pictures. You can suit with this material every type of form, scope, wall, curtain. You can see these pictures. We can do in a very different type of forms. So, ¿esta no es mi presentación? No. Ah, sí. So, as you can see, you can use in the same you exactly need as the in demand. In these pictures, you can see the roofs, envelopes. Here you can see the cells. We can say to manufacturer, put more or put less cells in the glass to produce the effect of more or less shadow we need, no? So this is very interesting. And very beautiful, very aesthetic. So I invite you, so ask us the form you need or the space you want to cover with this, because you will have a very good system generation, solar system generation. We can do with this solar energy the both solution, sell electricity to grid or make an isolated system or self-consumption system for the building, no? So it's quite flexible, no? You see the very good effect with the sunlight, and you are having in the same system a lot of properties: energy generator, aesthetic glass having, and isolated system. So I invite you to ask me for more information. And at the moment, it is all. Thank you very much for hearing me.
Thank you, Maria.
Thank you very much, Maria, for the presentation. I think it's very, very interesting, and you know, like you can shape everything that the way that we want it to be. Is good. So with your presentation, thank you.
Sorry, se me ha olvidado una cosa. Perdón.
Don't worry. Go ahead.
Sorry. And very interesting for the buildings, for the universities is.
You're not sharing now?
Yeah, I need to share this. Yes. Sorry, because it's the last new I have only in this week. I'm sharing or not? Yes.
No,
No.
you're not sharing.
The viewers.
Yeah.
It's only 2 minutes.
Yeah, it's okay. We still have time.
Solar Fox. Esta, vale. Also for public buildings, schools, universities, or I don't know, administration buildings, when we have done the installation, we can set this screen, big screen, who is connected with the monitoring of the system. So in this way, the university can set this screen in the main door, and I don't know, and you can show to all the people are entering the university the real production of the system. And this screen you can set with the specific data you can show. I mean, we can design the data you can show, especially, no? I want to show more of the saving energy in the battery or only the production. We can decide what's the exactly data you can show, and we can implement this big screen in the for publicity of the project, for example. So it's very interesting. It's the last news I have, so sorry for I forget. Solar Fox screen data showing is the name, no? So it is another item I want to explain. Thank you for the last news.
I think this is very interesting as well. If you want to show to the people in the universities for some certain information. Thank you, Maria. Thank you all the companies that came here face-to-face to present their solution, and the ones that are online. Thank you very much for your presentations. Now we open the last part of the event, is the debate and question and answer. So please, now is the moment. If you have a question or you'd like to know more, a little bit more about the solutions, about the training, about the tools, about everything.
You can write the questions in the chat and we can read the questions or open the micro.
Now at the moment we have Ines.
Yes, thank you. Yes.
Just like the mic, you should. So people on PC can.
Thank you. Thank you very much. I have a question. Actually, I'm transmitting, the questions of our university partners to the companies, and especially, particularly, I have a question to Isabel. Isabel from NDEF. If she can tell us more about the purification unit, and also about the nighttime operation of the system, of the hybrid solar panel system, because the Tunisian university is asking about these two items? I mean, how is a purification unit functioning, and what is the characteristics of this system, and how it is operating during nighttime?
Hi. Well, about the purification unit, we haven't included anyone in our system for the moment. It's just a possibility, okay? Because we just promote the ventilation, and in the air conduits you can install a purification unit. But for the moment we haven't done that. It's just a possibility of the future, okay? And right now with the COVID and so on, we think that is something that will be interesting. And regarding the cooling, that this is the first summer that we are doing the monitoring of the cooling at night. We use the fan that we use during the winter. And to give you some numbers, if you want, for an office of 30 square meter, okay, with 5 panels, we are cooling down the temperature 5 degrees during the night, okay, 5, 6. But we are just doing this summer, so it's the first time we are just taking different flows and things like that. So we are in that step, okay. The heating we have already proved, the cooling is the first time that we are doing, but we are cooling down.
Okay, thank you for these answers. And are you offering the ducts also, the duct system with the I mean, yeah, the ducts and also the units for heat diffusion, and I mean the units, how to say, the units we install in
the auxiliaries. Do you mean that, or yes? Yes. In our offer, we just offer the panels, the conduits, okay, the ventilation box that is also with the control system, and like 2 thermocouples, and that is what we include, okay, for the moment.
Okay. Thank you.
Well, one more question, Isabel, please.
Yes.
So, does the system allow to install a purification unit? For example, if the university decided to add a purification unit, yes. So, what type of it would be, like air filters only, or what do they need to?
Well, air filters we include it, okay. What we don't include, like an active system of purification, and I'm not an expert of that. I know that you can input it in the conduits. Right now in our offices we have it, but I'm not an expert. I cannot say you which one you have to put it. I know that you have to you can do it in the air conduit, okay.
So the system allows already to install one, a purification box, for example.
What? Can you repeat it, please?
The system allows to, so we will be able, if you want.
Yes, if you want, you can put in. Yeah, there's no problem. Normal filters we already included. Okay.
Okay. Thank you. I do have another question for Andres from Ingenium.
Yeah, Andres.
Hello.
Hello again.
Question for you.
Andres, when you were talking about the programming the system, you mean for example, we need to change the rules of the decision parameters of the system? Do the client, the final client, have the possibility to enter on the?
Yeah, there is like 2 steps of configuration. Okay, there is a first step in which a programmer, in this case, we also do sometimes the installation and the programming. So there is like a first step in which we prepare everything and we make like a first configuration of everything, but then the final user, the responsible of the university that will that will manage the system, can also, for example, create timings to turn on and off the lights at certain hours, can take all the decisions that I have spoke about, if I am above that consumption, I want to turn off this machine or this other machine. All these decisions, all this configuration part can be done from the user side.
Okay, thank you. And you are able to assist in both steps. I mean, even
Sure, for sure. Of course, we have many programming manuals and configuration manuals, and of course, we assist. We have a technical department to assist with any doubts or with any help that can arise.
Also, I would like to ask again about the necessary period you need to install the system. Actually, we already asked this question to your colleagues, and we got like an wide answer, not really precise answer, in the sense that they said it will depend on the actual situation of the electrical installation at the university. Yes, but we have.
Yeah, of course. Well, the system. If there is already a building with the installation, the better thing is to install a wireless system.
Wireless, okay.
Then, depending, of course, of what we want to control. I mean, we can only control the climate, or we can only control the lighting, or so depending on how big we want the system to be in the project. Depending on the size of the complete project, maybe a wired solution, if it's really a big project, maybe a wired solution is better. So depending on the size of the project, we have to study it and take the decision. But both systems, the wireless and the wired, work really good. So there is no problem to choose one or the other. It's only to save costs. I mean, to save costs in the installation, we can move from one system to the other.
Okay, thank you very much for the answers.
Okay, there is one question here in the chat. There is a question to Andres as well. It says that you talk about all the configuration could be modified by the end user, but is there any consideration for the real-time environmental conditions for that configuration ratios, or it is only based on the program designed by a person?
Not all the configuration can be modified. I mean, there is a first step that a programmer, in the first step, a programmer configures the systems, and that programmer can choose which things can be modified later by the final user, or which things are not possible to modify later. Then, as the system have the capability to be continuously modified in the computers, in the apps, we can take the data for the conditions, the environment conditions, and adapt the configuration of the system to that environment conditions. But the system will not do it by itself. I mean, we have to analyze the data, and with the data that we take, we can change the system configuration. For example, in the city projects that I have present you in the presentation, that we are working now in city projects. We have here in my region, we are testing this city project in a city called Gijón, and they are seeing, well, they have seen that some houses that are in concrete places of the city have a higher consumption that similar houses in other parts of the city. So, well, taking that into account, they are changing the program. They are changing the orders that they are giving to the different devices that they have in the city, and they are saving costs. So the system will not do it automatically, will not analyze the data and take decisions automatically. But as you have all the data, you can analyze the data and reconfigure the system to work with that conditions, special conditions of the place. Other question in the chat, I think.
Total integration.
Yeah. Another question is there any total integration of the different parameters? For example, taking in consideration illumination, heat gains, and occupation for a predicted configuration of HVAC, blinds, openings, and illumination in order to reduce energy consumption? And thank you for your first answer.
Sure. I mean, all the system is working together. So of course, I think I understand your question in that way. If it's not what you are asking, you can ask again. But as the system is working all together, I mean, the lighting is working with the climate, is working with the blinds, and all the devices in the system communicate with the others. So every single device in the system knows the status of the other devices. So you can play with the climate depending on the position of the blinds. You can play with the lighting depending on the climate. I mean, you can, it's a complete integration of all the systems in the building, and you can manage and take decisions with all the system together.
Yes, sorry to interrupt you. It's just a matter, what I was saying is just in the case of, for example, we have solar gains on a facade and we've got the blinds. But then if we close the blinds, we've got darkness inside. So we need to turn on lights. But if we open the blinds, we'll get the gain that we'll need to replace it with the HVAC. So somehow this automation is considering all these aspects to understand how the blinds may turn to keep some light inside, to avoid the heating, to have like a sort of predictive best option of less consumption.
Yeah. You can, I mean, you have the thermostat in the room that is measuring the temperature. You have the control for the blinds, and you have the lighting control. So of course you must configure the system to let the system know which is better. I mean, it's not only, you can say the system, okay, take the decision to save energy, the most, okay? But sometimes this is not the most comfortable option for the room. Imagine that it's, in this case, for example, imagine that it's better to completely close the blinds to save energy, because you will not need to cool the room, to cool down the room as much as if the blind is open. But maybe if you are inside the room, you don't want to have the blind completely closed. So, well, you can configure the system to tell the system your preferences. For example, in this case, you can say, okay, I have a presence sensor in the room. If I am inside the room, I want the blind open, no matter the energy consumption in this case, because I am inside the room and I don't want the blind completely closed. But if I am outside the room, if I am not in that room, then choose the system, tell the system to choose the most efficiency option. So, well, of course, the system can calculate the better option, but you must configure some preferences, because not always the cheaper option or the most efficient option is the most comfortable one. Okay.
Perfecto. Gracias.
Thank you. I think we have another question from Jose Luis.
Yes, yes, thank you, Leticia. Well, I have a question for manufacturers. It has been very interesting, the presentation they made. And it seems that it is possible to integrate in some extent renewables source of energy into the building, producing some saving on energy, on costs. But yesterday we were talking about the possibility of integrating in the tool that I have almost presented today, the prototypes that the manufacturers or during the project development could be selected as interesting. Then for integrating these elements, imagine one of the photovoltaics, for instance, systems. For integrating any of the system, but imagine the photovoltaics. In the program that I have shown, we need a prediction, the capability of predicting how much would be the energy produced by that system, that equipment, and the costs. Because if not, we cannot make an evaluation of the different alternatives between one or another insulation. Solution. Sorry. I mean, it's better to install a PV system, or you better improve the insulation of the roof. Then, for comparing, we need a model for calculating the output in terms of energy actually used by the building. You know, for the electric component, it's very easy, because if you have electricity consumption in the building, let's say 2,000 kilowatt hours, and the system, the PV system, produce 500, then you will have the opportunity to compensate one with the other. You auto-consume the electricity, and that's very easy. Then the only data that we need is how much electricity can be produced by that system, depending on variables that the computer program can provide, as solar radiation, orientation, number of square meters, or whatever, and how much is the cost. Then my question for all of you manufacturers is, do you have a model that can predict the behavior of your system? Because of, I'm finishing. I mean, when you offer that system to a client, you say, well, install that, and you can be sure you will be obtaining some saving. Or you use a model for predicting that amount. Because of that is the model that we need. That's all.
Yeah, so, for example, Maria or Isabel or Marilena. You want to answer Jose Luis' question?
We are not manufacturers, but of course we work with models every time, with a simulation models of a prediction weather and production of the systems we are installing. So of course we always work with a prediction and simulation models in each system we install, depending on three factors: in the location of the system, of the solar system, in the weather conditions, and in the efficiency of the material installed. No.
Mm-hmm.
So
Okay.
we work, of course, with models.
But could you provide us with such a model, saying, well, for us the electricity production, depending on the amount of solar radiation, area of the equipment installed, and I don't know, outdoor temperature is such amount.
Yes.
Imagine we will need. Sorry. We will need to calculate how much electricity can be produced during 1 year. We will expand our calculation for a complete year. Then how much electricity can we obtain from any system?
You have a lot of software. So one of these software is open. It's called PV3. You can enter in this software and calculate the production of a solar system, for example. There is a lot of software will calculate this forecast.
If I may, Professor, and just to put you on the scope. So yesterday we had a meeting with our partners from University of Sevilla and with the Solartis, and we wanted to explore the possibility of integrating your solutions in the decision aid tool that the university is developing. And in order to do so, we would need models of your solutions to integrate in this tool. So Professor was asking if it is possible to have models in order to integrate them directly in the tool that he is developing.
Yes, this is possible, no problem.
So the idea is to propose your solutions into the program which is developed by the University of Sevilla. So
yes,
it would be one of the options or optional measures, renovation measures that could be taken into consideration while renovating university buildings.
Yes, of course, we can share, and yes, no problem.
Okay, so the question of Prof. Molina was in this context.
Isabel, would you like to add something else?
Yes, in our case, if you have the thermal parameters and electrical parameters, it's the same. It's easy to calculate the generation, but in fact, we have already done for some end users that want to have more data, and we also give costs. So that I don't have in the presentation because I thought that it was like a general presentation, but we have already sent you for some of you the generation data and also the cost. So maybe we can send again, but we have already done that.
Fantastic.
Yeah, Jose Luis.
Sí.
Yeah, do you agree with what they said? Do you want further explanation?
No. I just wanted to raise that question. It's important for the manufacturer or the distributor or whatever to introduce their products in the final application that we could produce, that they can provide with a model of their performance, let's say. That's all. Just I wanted to raise that point. Thank you.
Thank you, Jose Luis.
there any more questions, doubts? Your lines? I think everything is pretty clear. We are on the left side. Do you have any doubts on the companies what they presented? No, that maybe for me is a general question. Our partner, Najah University, is considering to implement PV glass in order to build a solar tree with this technology. So just a general question that may interest also the partner, if they need to have, let's say, special considerations when building the solar tree with PV glass.
Sorry, I think this is very...
No. I can repeat. So our partner in Palestine, they are in Najah University, they are building a solar tree using PV glass, solar trees.
The solar tree we talk about.
Yes, exactly. Using the PV glass.
Yes.
Okay. And so my question is, are there any special considerations?
Configuration of the solar tree.
And that consideration, because I have searched that there were no, let's say, infrastructures done before using PV glass in order to build a solar tree. So my question, it is general, but it can be not relevant, I don't know. Should we consider some, or I don't know, make some special considerations when implementing the solar tree while using the PV glass?
No,
in the design or in
the structure of the...
In the structure of...
Yeah, in the structure you can take, you can give space to the connections.
To the
electrical connection, to the wiring.
Okay.
So I sent you before the wiring.
Yes.
So you need to respect this wiring. So in the structure of the solar tree, you have to be space the cables from the PV glass to the batteries, to the inverter, to the solar regulator. We need to have pass space, only that. Only that. It's the same of having a isolate solar system, but in different structure. So you have to be sure of the cabling pass.
Okay.
Only that.
Thank you. I would also like make a demand for all of you. We need some. We will for sure need some help, and we are doing it with the partners. We are elaborating the terms of reference for acquiring each one of the systems. And as you know, universities are public institutions, and most of the time they don't have they don't have the necessary staff, technical staff to write terms of references and to elaborate the tender dossier or document. So we will need, we already asked you, and you answered our demand on some characteristics of the systems. We maybe need also like some reference documents or some typical terms of references you have already used for previous tenders, yes. So this is one of the things that can be really useful and helpful in our project cases. And yes, we will like ask more specific questions for each one of you, but this will be really useful if you can share with us some or documents or
or typical terms of reference you already used in the past.
But the procurement strategy of this, for these interventions,
yes,
do they allow?
No, it will not be one like direct procurement. We cannot select.
It has to be public. No?
Yes, yes, it has to be public, but we have also the possibility to like target solution requirements, and we can also what we are doing most of the time is to get the help of manufacturers, suppliers, yes, solution suppliers to make us sure that we are describing solutions in which they can be make an offer. It's really important. And most of the time when it is innovative solutions, we can also justify the fact that we like target a small set of companies, and universities have this possibility actually. So yes, we will not be able to like do direct procurement, but we can target some small group of.
Well, thank you. I guess we don't have more questions here in the chat. This is the last chance for you. And here we have a question that this is the last chance. I think we are only 6 minutes to half past 12. So I think we are on time. Okay, so thank you very much everyone for coming. I think we'll leave it here. It's only and we will send you the further information about the trainings once we have everything defined, about the content, the target audience, time frame, and see how the COVID situation goes. Thank you also for the speakers online. Thank you for coming here today to everyone. Have a good day and see you on the screen. Thank you.
Thank you.
Thank you.
Thank you.
Bye. 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 Thank you.
Thank you very much.
Thank you.